All right, so welcome, my algebras, to equivalent figures exam questions. These guys don't actually have an actual question, but that's what we do when we deal with C1s. Right now, let's look at the first part of this guy here. We've got tiles made of cork that will be also used for the new cafeteria floor, shaped like this guy below. If the cork tile was cut along the dotted lines that you see, you would have new segments that are made. Here is the crux of these questions. These guys right here, okay? That is basically everything. So let's unfreeze this guy so you can see what I'm doing. No. So this is the crux of everything that we're going to need to work on. And what I want you to identify is the first thing I always want you to identify is number one, where is the equivalency statement, right? And this one's weird. And that is the statement. Rectangular section ABCD is equivalent to BEFG. Okay, so ABCD is equivalent to BEFG. Okay, they didn't say area is equal to area, they used the word equivalent. So the one thing I haven't kind of mentioned before is if they mention this phrase, what they're actually telling you is that the lengths could be equivalent, the areas could be equivalent, and for prisms, the volume could be equivalent as well. So you could use all different types of measurements to approach these guys.
I'm pretty sure in this case they're saying area.
Exactly. You're reading my, because it says the only thing I have is area, because this is like just like a 2D, like this is just a square with a bunch of rectangles in it, then we're not too concerned. So you're right to be able to identify that it's area. Here's the only thing now. So when I start this guy off, I know it's going to be area of, where is it? ABCD is equal to area BEFG. We okay in the back there?
I'm not sure they are.
You're not being very good algebras right now. I will not edit this.
He wouldn't get it.
No. So if I look at this here right now, okay, before I go anywhere, I know that like the breakdown of this guy is going to be, let's just go like even further into this. It's going to be AD times AB, right? So it's a rectangle, so it's going to be length times width. Okay? I know this guy's a rectangle, so it's also going to be length times width. So BE multiplied by EF. Okay? So that's just because area is equal to area.
Why not BG?
It could be BG if you wanted to. It's just I'm using it purposely because it's the exterior edge, and it's going to leave that. You could do both. It's going to be the same thing. Good question. So now I really want you to label everything. So step 2 should be like, let's go through and label all that we can. Let's make this a little bit clearer. Step 2, label. What I mean by that is AD is x plus 1. BE is x. That is all I know. So right now, if I look through this and try and build my equivalency statement, because that's our second step, is to input the values, build the equivalency statement. So I know BE is x, but I don't know what EF is. I know that AD is x plus 1 as a binomial, but I don't know what AB is. How can I get those pieces with the information I've already been given? Some of you already started it, and it's the one thing I want you to do. If you got here and you're like, no idea what to do from here, what's the only math skill that you can execute right now? Yeah? Factor the area. Right? That's the only thing, like, really, our skill set right now tells us that the only thing we can do is factor that. The rest of the stuff, I don't know, that's missing and that's missing. But I don't know, let's just factor it and see what happens. Okay? So step 3, in this case, factor area. Now, I saw some of you going through the long way. What did it tell you at the beginning of this question? Each quartile is shaped like a square. So that means we don't have to think about it.
I already know AH and AE have to be at least 5x.
Right. I don't need 5x plus 3 squared. I don't need to think too long and hard about it. If it tells me it's a square, that means it's a perfect square, meaning the factored answer is just 5x plus 3. If you went through the long way, are you wrong? No, not at all. Still works. It's just, and actually 5x minus 3. 5x minus 3, because I just didn't see the negative 30 there. 5x minus 3 square. So now that I have that, let's continue to label what we know. So I know that means that this side length is 5x plus 3. And I know that that length is minus 3. Thanks, Deegan. I knew you'd catch that too. Minus 3. Minus 3. So now that I have this piece and this piece, can I figure out what AB is? Darn tootin'. Yeah, I just said that. So if the full length is 5x minus 3, what is AB going to be? 4x minus 3. If this full length here, right, is 5x minus 3, and AD is x plus 1, what is, actually, I don't even need that. We just need the AB, which we have, and we need EF, so we're basically good to go.
I labeled it anyway.
Yeah, I wanted to, like when I first did it, there's nothing wrong with it, right? To find like the segment DH.
There's nothing wrong
There's nothing.
with wanting to label everything.
Love it. Shows you know what's going on. So we're going to add things in now. EF was 5x minus 3. AB is now 4x minus 3. Now the rest of the steps, now everything else from here is the same. Okay? A lot of these questions are going to be kind of like this. The setup's going to be the hardest part, right? And that's why like the execution of these steps going forward has to be like automatic. So 4x squared minus 3x plus 4x minus 3 is equal to 5x squared minus 3x. So we just, at this stage here, right, we expand. So I'll even write it down right here. Expand and combine. Or you can say set to 0. Or you can say monster mash. I don't care, whatever sticks in your head, do it whatever way you'd like. So I'll just continue this guy out because I want this recording to have it from beginning to end. When I say set to 0, I love having my a x squared being positive. I'm just going to make this stuff prettier before I bring it over. And then all these pieces. So I'll be subtracting x, I'll be adding 3, and I'll be subtracting 4x squared, leaving me with x squared minus 4x plus 3. Now, I don't think you'll need the quadratic equation, but I'm just going to say at this stage, factor it or quadratic equation it. All over 2a. So now we just factor or. So shouldn't be hard to figure out two numbers that add together to get -4 and multiply together to get +3. It's -1 and -3. And because a is 1, my answer is just x minus 1, x minus 3. Now, my last step here is solve for x. So we break this guy into two. X minus 1 is equal to 0. X minus 3 is equal to 0. So x can either be equal to 1 or it can be equal to 3.
It's actually both.
So then that's where that last bullet point comes into play now. So now if you go up, geez, they're both positive. They both look like they would fit this scenario. But let's try the first one. If x is 1, then AD right here is going to be 1 plus 1, which is 2. If x is 1, BE is also going to be 1. So where does this thing come into play? Measurement AD cannot be equal to 2 times BE. So if I found the numerical value of this and found it to be 2 using x is 1, if I found the numerical value of BE, finding that it is 1, 2 is equal to 2 times 1, yes. So that means I would reject that one because that little symbol there is telling me it cannot be. So this is why we reject x is equal to 1. Strictly because of that bullet point there and for no other reason. Okay? Because it could be both. It could be both. So that is it in a nutshell. They're all relatively similar to this, but this one's a great starting example for like a C1 equivalent figures, which is where you will see this.